Hello, everyone. We're going to look at the quotient rule. Now, the quotient rule is how you differentiate when you've got a function of x over another function of x. So what we've got here is the u is representing some function of x over the v, which is another function of x. Okay, so what ends up happening is the derivative is you go v times the derivative of u minus u times the derivative of v all over v squared. Now, that doesn't make much sense yet, but let's go through and have a look at an example. So, what if we were to do, we were to have a look at this example. So if I have a function and I've got x minus 1 over x squared plus 2. Now, what you can see here is you've got your u, okay, that's a function of x over, let's do a different color, v. It's also a function of x, but it's been divided. That's why we call it the quotient rule. So let's go ahead and do this one. So let's follow the rules. The derivative is equal to the v, so that's x squared plus 2, stick it in brackets, times the derivative of u. What's the derivative of x minus 1? Just 1, minus the u, which is the x squared minus 1 times the derivative of the v. And the derivative of x squared plus 2 is just 2x. Now, all over the v, or the bottom function, oops, the bottom function squared. Now we just need to make that look a bit prettier. So let's clean it up a little. Well, 1 outside of something doesn't change it, so it's just x squared plus 2. Now, I'm going to put the minus 2x in the front here. It's all over the bottom function squared. Now, just a reminder to everyone that when you expand brackets, both things get multiplied. So let's expand out the top, x squared plus 2, then minus 2x squared plus 2x, all over the denominator squared. Now, and now we just tidy things up a little bit. So what can go together? Well, we can do the x squared is like terms with the minus 2x squared, and there's nothing else there that can go together. So x squared minus 2x squared is minus x squared, plus the 2x plus the 2, all over x squared plus 2 all squared. Now that's the end. It could be possibly written in a different order at the top, but that's the end. Okay, let's do another example. What if we were to do something a little bit more complicated? We have a function of x over another function of x. Okay, is it a quotient? Yes, we've got some function of x over a different function of x. Okay, u over v, it's just a function of x over a function of x. Let's follow with the rule. Okay, the derivative is equal to the v, or the bottom. I think of it as the bottom. Differentiate the top, or the u. So what's the derivative of ln x? It's 1 on x. Minus the top, or the u, times the derivative of the v. So the derivative of x squared plus 1 is 2x. All over the denominator squared. Okay, now let's clean this up a little bit. Like we said before, you have brackets. You can expand with the number out the front. So let's clean that up a bit. X squared over x times 1 over x is just x, plus 1 on x, minus, now the 2x, we would just usually write that in front of the ln x. Now this is pretty much done, but what you usually find, and if you had that question in your textbook, is they don't usually like fractions in fractions. And so what they would do, I'll use a different color to show you. I think they would go like, let's times all of that by x, and let's times all of that by x as well. So then I'm really only multiplying by x over x. I haven't changed the value of what's there. Right. So what happens at the top if I times everything by x? So if I have everything times x there, each term times by x, what do I get on the top? I get x by x is x squared. X times 1 on x is just 1. And x times 2x ln x, to keep my minus, I get 2x squared ln x. And what do I get on the bottom? I just get x times everything. X times x squared plus 1 all squared. Now, on the top, there are no like terms. If you look at the top of the numerator, you've got x squared, you've got a plus 1, and you've got 2x squared ln x. There are no like terms. That's as far as you can go. Okay, what about if we have the question slightly different? Let's have a look at this example. We have a function f of x is equal to 2x cos x, and you're asked to find f dash phi. What does that mean? Well, it still means you've got to find the derivative. Now, the derivative, have a look again, people. We've got a function of x over another function of x. So it's the quotient rule. You can use the quotient rule. So we have, okay, so the bottom, differentiate the top, differentiates 2, minus the top, differentiate the bottom, cos x goes to minus sine x, all over the bottom squared. So cos x squared is just cos squared x. Okay, we can make this top a little bit tinier. We don't usually put cos x times 2. We would say 2 cos x. Now have a look what's happening here. We've got this minus sign there and minus sign there. They are crucial points of where people are likely to make an error. A minus times a minus is a plus. And so then we just have 2x sine x all over cos squared x. Okay, but the question wasn't actually just to differentiate it. It was to find f dash phi. That means in the derivative, substitute the x with pi. 2 times pi times the sine of pi all over cos pi squared. Now, over here to the side, I'm going to write, as I would always do, my little reminder about, so that's my cos graph. It's very accurate, doesn't need to be. I just know that that's 2 pi, that's pi. Okay, reminding myself what happens with cos. And then I'd also remind myself what happens with sine. And that's 2 pi, that's pi sine. Okay, because that means I can then do my substitutions really easy over here. Okay, so I'm going to go 2 times the cos of pi. Okay, if I look over here, I can see the cos of pi gives me minus 1 plus 2 pi times the sine of pi. What's the sine of pi if I go over here? Sine of pi is 0 all over the cos of pi, which I already worked out was minus 1 squared. Okay, then that means I can now work this out. 2 times minus 1 is minus 2. That's 0. It just goes over what's minus 1 squared. That's just 1. So minus 2 over 1 is just minus 2. And that's done.